Welcome to the Airline Pilot Podcast. I'm Jason Ambrosi. As the largest non-governmental aviation safety organization, ALPA keeps close ties to our partners in safety across the industry. Today, we're joined by one of those partners, Akbar Sultan, the Director of NASA Airspace Operations and Safety Program. This program plays a key role in researching and identifying safety threats and opportunities. Thank you for joining us, Akbar.
Thank you, Captain Ambrosi, for having us today here.
Absolutely. Before we jump into the meat and potatoes, I'll say I come from largely the industrial side of ALPA. However, our roots are in safety since our beginning in 1931, and it's been great seeing firsthand the incredible work our volunteers and staff do on the safety front every day. And I'm excited to communicate these efforts on behalf of our listeners. So NASA and the FAA have been great partners for decades in mitigating risk in aviation through the Commercial Aviation Safety Team, or CAST. Would you give our listeners a bit of background on the work and some of the developments and processes NASA has helped to build?
Certainly. So first of all, NASA has a very long and rich history in aviation. We go back to 1915 when it was originally NACA was established, the National Advisory Council on Aeronautics. And you go in what we say today is NASA is in the DNA of aviation. So when you fly, whether it's a ground-based system or an avionics system or an aircraft system or engine, you won't necessarily see a NASA logo on something. But we've had our hands on it somewhere down the line as the aviation has evolved. So, for example, if we look at some of the big advancements in the 1970s, we helped promote and spearhead crew resource management, which had a big change on how we fly aircraft today and how we make decisions in the cockpit. In the 1980s, we helped develop the enhanced vision systems and synthetic visions and for operations in low visibility conditions. And of course, as we look closer in, more recently, after the unfortunate Colgan Air accident, we actually led 6 safety enhancements under the Commercial Aviation Safety Team for prevention of stall and helping with upset recovery, which essentially was, if you look at the simulators that were used for stall recovery operations, the earlier models were very much linear models, which said, the plane is flying steady, and then there's an issue that says you're installed, but however, the simulator was still perfectly flyable. It did not have that mushy feel, or the controls were, for example, not reversed. It could not emulate a proper stall properly. So we enhanced those algorithms so that now a pilot can truly experience in the simulated environment what it feels like, such that when, should they unfortunately have that encounter, they have a better muscle memory on how to react to it. So that technology has been now transferred to all the aviation community for use. As well as being able to enhance the algorithms to train them for upset recovery conditions. For example, I used to sail a long time ago, and if you're a sailor, you can know that sometimes you stall your rudder, right? You need to reverse the rudder in order to reattach the flow, and that same thing happens with upset recovery conditions. So these are some of the main things that we have helped develop. And then if you look at CAST, it was formed in the 90s, and in that same time frame, NASA led the effort to show that using data analytics, you can try to go into a more proactive safety environment to be able to identify some things, precursors to accidents or incidents, or to identify trends. And that capability very much resulted in the creation of ASIAS in the early 2000s. So as you can see, we don't necessarily have an ownership of something. However, as aviation has evolved, we've had significant contributions throughout certain timeframes.
Yeah, that's incredible, and it's amazing to see the work that so many different organizations do together to keep that level of safety getting better, right? If at any point in our history we said, okay, we're safe enough now, as the system get bigger and bigger, there'd be numbers of accidents that would be never acceptable. So the fact that your organization, our organization, so many other organizations strive to have an increased level of safety, and even now that we're in the safest period in history, keep pushing that bar higher and push that bar forward. But so, what are you working on or researching now to mitigate risk?
So our primary focus right now is on this concept called in-time aviation safety management system, which is how do you go from the current environment of a reactive and proactive environment to a more predictive environment, and using data analytics and automation to do monitor, alert, and mitigation of safety events and looking for those precursors. Okay. So that's in the early stages of the research that we're currently doing a lot of work on.
How does that work? What you just explain that a little more, if you don't mind.
Certainly. So, for example, I might give one example is looking at missed approaches. So, for example, if using data analytics and everything that's going on in the flight data recorder and using those telemetry data and looking at the state of the NAS in the region and looking at what all the other aircraft have done, winds, weather, the state of the pilot, how many hours they have had on board, and and what is their state of alertness, everything else that's going on. So a tremendous amount of data analytics can be at play. And being able to look at that and the aircraft state and say, before the pilots are able to actually make a decision for a go, no-go on a go-around, having the algorithm be able to say, almost 30 seconds and sometimes up to a minute before, stating that given the current aircraft state and the approach path and everything else that's going on in an NAS, maybe you should do a go-around at this higher altitude, higher energy state. So this is kind of like an algorithm that we've been able to research in the lab environment, of course. But this is something that can have application in the real world. So this is now getting into that more predictive automation environment, being able to assist the crew and being able to essentially have automation, do this human-machine automation teaming. Because at the end of the day, the human is fully responsible for the vehicle safety. So how do we add additional enhancements and capability for that decision making?
Yeah, identify the risk earlier, I see, is what that sounds like. What other trends has your office recently identified or areas in which we could do something to improve safety beyond where we are today?
We've looked at a couple of things. So first, of course, runway incursions and wrong surface approaches and those things, I know have been making a lot of headline news. NASA has developed a capability that using ADS-B in, which unfortunately is not widely deployed, right? But if aircraft that are ADS-B in equipped, you could provide the crew some additional alerts and information in the cockpit, both for aircraft on the ground as well as on the approach, in order to be able to avoid runway incursions or wrong surface approaches. This is a capability that one can look at it from two sides. One is say, of course, it enhances safety. But from the other perspective, I know with the airlines and having to equip, there's always that first question they always ask, right? Well, you have this new technology, ADS-B in, why should I invest in it? So this way we are able to now say that, okay, if you were to invest in this technology, now this is a reward that perhaps you could get out of that equipage. So that's a return on investment. So that's one of the things, for example, that we've been looking at.
That seems like a simple one, if I might not say so. ADS-B in, that it just seems like common sense because it gives you more situational awareness. As a pilot, situational awareness is great. So just like you said, runway incursions or wrong approaches, just having that situational awareness, it seems like a no-brainer that would be an investment that airlines and industry would want to make.
Absolutely. But as you can see, I mean, you are a pilot.
Cost, right?
There's a huge cost, and airlines they're not high margin endeavors. So this is where what we try to do is just because of that, we try to create capabilities and technologies that can piggyback off of tech investments such as ADS-BN. So this way, for example, we can say like, okay, if you do invest in ADS-BN, what additional capability enhancement could I provide you? So this safety is an example. We have developed a couple of additional tools, for example, to reduce noise emissions and fuel. That's actually in demonstrations out in Dallas-Fort Worth and Dallas-Love Field with a few airlines that are saving tremendous amount of fuel, for example, with a few of our airline partners out there.
Yeah, that's great. Going way back, NASA's ASAR's Aviation Safety Reporting System, and other confidential safety reporting systems like ASAP, at the airline level, that most airlines have implemented are vital tools in understanding the trends of safety. How does NASA and other groups utilize this information provided by actual line pilots out there in this environment, and what value does that contribute to the research projects?
So first of all, if we look at systems such as ASRS, it's like a better word, it's a wealth of information. You can get almost like approaching almost 8,000 reports a month, for example, that are received within that system. And of course, you can also even supplement it with SIS, which has additional information on data fusion, for example, as well. And you heard me talk a little bit, a few moments ago, talk about automation and using automation to help monitor, alert, and mitigate a potential safety hazard. So for these algorithms, they need a lot of data in order to sort of normalize to say, what is a safe event and how do you now look for that outlier? So in order to make sure that we are able to detect that potential outlier correctly, because at the end of the day, you don't want to have too many false positives, right? False negatives. I'm sorry. Okay. So this is where this tremendous amount of data is extremely crucial for us. We are able to use that data and mine it, and then help train the algorithms to make sure that we're not missing anything. So those are like the false negatives that you perhaps you missed as something that you should have flagged, and or we're not having too many false positives where we're flagging a lot of things that should not be flagged. Because at the end of the day, you want the human that's using the system to have trust in the system. Now, if you have false positives and negatives, that trust, of course, is lost on automation. And that's the worst situation one can have in an aviation environment where the human and machine, that connectivity is now, for example, has been compromised.
That's interesting. We talk about the line pilot's perspective. What is the importance of the line pilot perspective from our ALPA representatives, and when we work with government or industry work groups like yours?
So, to put it simply, line pilots are the domain experts. You all know as to why something should be done the way it is, or why something happened the way it happened. And having that crucial information is tremendous. And also, at the end of the day, what technology needs to be developed to be helpful to you. Because if NASA develops our technologies and we do it in a vacuum, we will maybe develop a very wonderful tool that works perfectly fine in a lab environment. However, perhaps it is not implementable and deployable because it's going to be arduous to deploy in a real world environment. So that's why we try to engage with the end users as early in the research phase as possible. We actually try to engage with our users almost at TRL1 at very low maturity levels, so that we may have a concept, but how do we shape the concept such that at the end of the day it's useful to the actual deployed entity, and also get that feedback to say, this is how you should perhaps evolve and change the concept. This is what's useful information for me. Going back to what I said a moment ago in terms of those data and data analytics, providing additional data to a user is not necessarily helpful, because at the end of the day, data is not necessarily information. Data needs to be translated in a form that is useful and digestible by the end user. And this is the tremendous feedback we get from the aviation community.
I can say as a line pilot, of doing this now, but many years of flying out there, I appreciate when our perspective is listened to, because we, like you said, we're in that environment day in and day out, day and night. Shifting gears a little bit to all the new entrants. We have so many new entrants. There's going to be a clogged NAS here before too long. How will the air transportation system need to adapt to keep such a safe operating environment?
Well, aviation is changing tremendously, and especially with the advent of new entrants, because if you look at the new entrants, it's going to bring far more set of, the diversity of operations is going to be higher. Because if we look at the current aviation, it's, tube and wings, right? And a few rotorcraft throw in, a few GA throw in. And the modes of sources and sync of the operations are primarily airport to airport or vertiport to vertiport. However, with new entrants, you can sort of see that the performance characteristics of just these vehicles is going to be far more diverse. You could have, for example, if you're looking at the upper atmosphere, you could have a supersonic aircraft going through an airspace at Mach 1.5, occupied by a HAL that's going at 15 knots. Right? Just the diversity of the performance. And the diversity of the missions is going to be far higher. So, of course, that leads to, and also the density is also going to be much higher, in that, the current NAS maybe is about 50 to 70,000 operations a day, depending if you exclude or include the GA. We could foresee going into an environment there's millions of operations if you start looking at the small UASs, large UASs, and advanced air mobility.
It's hard to believe, isn't it?
Exactly. So given those two things, there's going to be higher levels of complexity. So therefore, we have to start looking at an environment to say, how do we add additional automation to assist the human? Because if we say that the human alone is by themselves responsible for the safe operation of that environment, I think we can all agree that the bandwidth and reaction time is going to be stressed for a human operator. So therefore, how do we introduce additional automation to assist the human, such that we can provide him that predictive risk and predictive safety services and capabilities to assist them in the safe maintenance of the current aviation system? And one can also look in terms of the society's acceptance of safety events, where one can look and say, well, in the United States we have the safest aviation in the world. Perhaps one can extrapolate, say, one fatality every 10 to 15 years. And if we say we're going into an environment we're going to have millions of operations, one can't just extrapolate and say, okay, we're going to have 1 million fatalities every 10, 15 years. Society is not going to accept them. So that's where, as we try to enhance the safety several-fold, that is going to be our challenge in making sure that we have the right capabilities and technologies to be able to assist the humans in that endeavor is going to be the key.
Yeah, and properly integrating all these new users into the airspace is essential, right? You can't have a drone delivering a package wandering across the approach path here at DCA or something like that. So that the work is cut out to make sure that all the new entrants are operating in a way that keeps everybody safe, the traveling and shipping public.
Absolutely. That's one of the main focus areas of NASA's research on the new entrants and advanced air mobility and UASs. Is essentially the two focus areas are integration into the NAS, and how do we integrate these vehicles safely with existing operations, such that any and all vehicles can cohabitate and coexist harmoniously and safely. And then the second aspect is the safety capabilities and services for these vehicles.
So we talk about fatigue a lot. With more operations, especially coming out of the pandemic, fatigue has become an issue for many of our members because the airlines had a tendency to bring back flying faster than they could, or maybe some should have because we had the airplanes, but less pilots because of early retirements and stuff. But again, fatigue is front and center. Some of the research that NASA's conducted is crucial to gaining an understanding on fatigue, how it impacts pilots, and how it impacts safety. You're currently studying and you're wrapping up a fatigue research sometime this summer. Is there any insight into that, or any kind of data your team's looking at? Let us know a little something early is, I guess, what I'm asking.
Sure. So we're working with several airline partners, both domestic and international. And the primary objectives are essentially to look at circadian rhythms, for example, and being able to identify, the effect of that on the pilot's alertness, and also look for scheduling of the crew. Because no two humans are alike, right? Mm-hmm. We all have different circadian rhythms, and we are all, there's people that we say they're the morning people, afternoon people, and late day people, right? And some people are much better in the evenings. So how do you, given the natural rhythms and alert states of each crew member, is there a way to be able to schedule them such that now you're putting the crew members on the most optimum schedule given their most alert circadian rhythms, rather than this one size fits all says everybody is doing red eyes? Well, some people are better at red eyes than others. So how do we do that crew resourcing? We have looked at, for example, the cockpit lighting conditions, and being able to say, okay, are there certain lighting situations better than others for first of all for each individual pilot, but also for the hour of operation and the duration of the flight. And other things that we have looked at, for example, is the development of this little tool that we've developed. It's a pilot alertness tool, PBT Plus, and it's been used by several airlines in the United States, where essentially it's this iPhone app-based tool that one can enter your sleep cycle information, but also do a little test. And it immediately provides that information back to say, okay, what is the state of alertness for the individual, such that the individuals and the airlines can make better informed decisions. So these are some things that have been studied through this study that you mentioned. But of course, human fatigue and human factors is going to be an ongoing work. So even though the current study will wrap up shortly, we intend to be carrying on our investment there going forward for other purposes.
Speaking of human factors, could you speak to how human factors and how the resiliency of pilots, humans, contribute to the safety of flight operations?
Certainly. So here I would like to quote one of our colleagues, Kim Pyle from FAA's AVS. She's been using these words quite a bit in terms of the humans have the 3 C's, curiosity, creativity, and compassion. And that is something that automation does not have. And at the end of the day, it's those, among many others, but at least those 3 traits that a human provides. Always leads to a safer, operation and environment for aviation. And this is, one can also look at, how do we use the human contributions to safety, and what is each pilot doing on a daily basis that's leading to the safe operation of the NAS. And how do we use the inherent ability of a human to be able to contribute to safety and do the appropriate human-machine teaming? because if you're providing additional information and assistance through automation, we want to make sure that we avoid mode confusions, right, or any other things. And one of the things that, for example, I would even go as far as to say is perhaps a misnomer is when somebody says, oh, this was due to a human error. And I would kind of strongly suggest that nobody wakes up in the morning and says, I'm going to go to work today, no matter what they do, no matter what line of work they're in. I'm going to go and have a human error today, no matter what line of work you're in. If one does occur, there's always a contributing factor. So being able to look and avoid and remove those contributing factors that lead to that. So those are what our focus areas are in being able to make sure that the human does not have these additional distractions or additional contributing factors that essentially gets in their way of maintaining a safe environment.
Absolutely. I couldn't have said that better myself. Well, thank you for joining us today, Akbar. Safety in aviation is truly a team effort, and we appreciate the work you and your program are doing to strengthen safety in aviation. Beginning this month, you can read more about the work of the Airspace Operations and Safety Program in a series we're doing in collaboration with NASA in our magazine. I also want to thank Captain Wendy Morris, our National Safety Coordinator, our ASO chairs, and the hundreds of pilot volunteers and staff that make up our air safety organization and engineering and air safety. Their tireless efforts have contributed to the safest period in our history. However, the work continues as we always strive to improve safety in carrying our passengers, fellow crew, and cargo. Thank you for tuning in to this episode of the Airline Pilot Podcast. If you haven't already, make sure you subscribe so that you do not miss any episodes. And if you enjoyed this episode, let your fellow crew members know about the show. If you have any questions or topics you'd like us to cover, reach out to podcast@alpa.org. To listen and subscribe to the Airline Pilot Podcast or learn more about ALPA, check us out online at alpa.org or find us on all major podcast platforms. Until next time, this is the Airline Pilot Podcast. Production copyright ALPA 2024, all rights reserved. Thanks and have a safe flight.